Beautiful. Okay. Awesome. So today's learning objective is to solve for lengths of special right triangles. So we're going to go ahead and go through a series of special right triangles. I'm only going to focus on one for today. Okay. Now, we've seen these type of triangles before. We just haven't seen them in this format. We are going to see radicals. So I'm going to go ahead and do like a little side note of how to simplify radicals whenever we multiply radicals and whenever we divide by radicals, okay? So I'm going to go ahead and do some little bit of side work so you guys can refresh your memory on all of that. So with that said, here's our learning objective, solving for lengths of special right triangles. So these are our two beautiful special right triangles. And we're going to ask ourselves, how can we find the lengths of those sides that are missing or that are not present? So the first triangle that we're going to see, it's actually this one. We call it the 45, 45, and 90 triangle. The reason why we call it is because its interior angles are 45, 45, and 90. The second one is 30, 60, and 90. Okay, today we're going to go ahead and see this one first. So here it is. Let me go ahead and introduce it to you guys. Go ahead and copy this one down on your beautiful notes and title it type of right triangle 45, 45, 90. Let me go ahead and draw this triangle that we are more familiarized with. This one right here. Right here. And let's say that this beautiful triangle is a 90-degree triangle. Therefore, this side is going to be 45. This angle is going to be 45 degrees. Therefore, my base angles are congruent to each other. What do we know about my beautiful opposite sides? Do you guys remember this triangle, seeing it last semester? No? Whenever we have base angles that are congruent to each other, what do we know about the legs in this beautiful triangle? Not the angles, we're talking about the lengths. They're what? They're congruent to each other. So these two are going to be congruent to each other. So this triangle is basically the same triangle that we have here. These two lanes are going to be congruent to each other. All right, so we know that, right? Those two lanes are going to be congruent to each other. We have what we call an isosceles triangle. Isosceles means that we have two congruent sides. Okay, guys. Now, from here, we're going to go ahead and assign a length to one of the sides. I'm going to go ahead and assign this one a measurement of 1. We just want our basic triangle. So we're going to go ahead and assign the measurement of 1. Therefore, if this is 1, what is the measurement of this side? 1. All right, so we have 1, 1. And because we have a right triangle, what have we done before in order for us to find the measurement of a hypotenuse? Not using sine or cosine or anything else. What did we do before using trig ratios? All right, so what have we used before in order for us to solve for beautiful hypotenuse? It's on my board over there. What have we used? What is that over there? The Pythagorean theorem. And what length is this? Is this my leg? Is this A, B, or C? This is my beautiful C. So we're going to go ahead and solve for this length using the Pythagorean theorem. So this is my C, this is my A, this is then my B. So therefore, C squared equals A squared plus B squared. Okay, so C, we still don't know what it is, so I'm going to leave it as C squared. A squared is 1 squared. B squared is 1 squared as well. And what is 1 squared equal to? Bless you, bless you. 2. Is it 2? It's 1. So 1 plus 1 is, therefore, you're going to let us do it fast. Okay, 2. Now, what is the inverse? Because we still have C squared. We need to isolate beautiful C. What's the inverse of square? I can't hear it, guys. There you go. I can't wait to hear your nice, beautiful voices, guys. Square root. So therefore, C equals the square root of beautiful 2. So the length of this side is going to be square root of beautiful 2. So we're going to go ahead and leave this triangle as our basic triangle, and all of the other triangles that we have that we compare to this one, whether their lengths are 1 or their lengths are anything else, we're going to go ahead and leave it as our figure 1. That's our basic or a base triangle that we're going to go ahead and make the other triangles that we're going to see from now on similar to it. Okay, so we're going to go ahead and make our triangle 1, 1, and square root of beautiful 2. And we're going to make everything else similar to it. Okay, now everybody has this. Yes, okay, perfect. Let me go ahead and clear. Ready for our first example? All right, so here we go. Go ahead and write this one down. Find the missing side lengths. Leave your answer as a radical in simplest form. So we're going to go ahead and have some radicals here. I'm going to go ahead and refresh your memories on how to simplify radicals so that you can go ahead and leave it in simplest form. Okay, so go ahead and copy this one down. So here we go. Now we have what type of triangle here in this case? We have 90 degree, we have 45, therefore the last angle is also 45. So we have a 45, 45, 90 type of triangle here. So we're going to go ahead and compare it or make it similar to our basic or basic triangle. So we already constructed the sides. We said it was 1, 1, and what was my hypotenuse? Square root of 2. So this is the triangle that we're going to go ahead and make it similar to. Now, which lines do I have to find here? A and B. Now, we said that whenever we have base angles, my legs are congruent. So if this side right here is 40 across or opposite to 45 degrees is 2 square roots of 2, what would be equal to? 2 square roots of 2. So B is going to be equal to 2 square roots of 2. All right, so we found B. Now A, we're gonna go ahead and do A. We're gonna go ahead and create our ratios. And I'm going to make this as my figure 1. This is going to be my figure 2. Figure 1 over figure 2. This is going to be my base. Yeah, this is going to be my figure 1. So I need to solve for A. A is my figure 1, my figure 2, so it's going to go on my denominator. Figure 1, A is corresponding to what length in my figure 1? Is it 1? It's my hypotenuse, so it's square root of 2. All right. Now, what other length is given? I'm given this length from figure 2, 2 square roots of 2, and this is corresponding to 1, so it's going to be over 1. This is where it gets fun, guys. Okay, I need you guys to pay attention. So we're gonna go ahead and cross multiply. So we have A times 1, A, square root of 2 times 2 square roots of 2. I'm gonna go ahead and write it out. Square root of 2 times 2 square roots of 2. Whenever I multiply radicals, I can go ahead and put the numbers inside my square roots inside together. So this is what I'm talking about. I'm going to go ahead and make some space right here. A equals 2 times square root of 2 times 2. So did you guys see what I did? Notice here that I had square root of 2. Square root of 2, since I'm multiplying them together, I can write them both inside of my radical. Okay. Now from here, let me go ahead and simplify. A equals 2 times, what's 2 times 2? 4. So this is square root of 4 now. What is square root of 4? 2. So A equals 2 times beautiful 2, which gives me beautiful 4. Woo! So A equals 4. Not too bad, huh? It's just following the items step by step. So we're gonna go ahead and follow with the items here step by step. Multiplying radicals, we still follow the same rules. And then we can go ahead and simplify. Ready for the next one? Ready, guys? Not yet? Are you guys still copying this down? Your what? Yeah, close your Chromebook. You don't need it. So go ahead and copy number 2. Find the missing length sides or side plane, sorry. Leave your answer as radical in simplest form. Zoom here. Okay, so this time we're gonna go ahead and compare it again to our basic triangle. What's our basic triangle? What are our lengths? If it's a 45, 45. 90, what is the side of this length? Or the length of this side? 1. And what about this one? And this one? Square root of 2. Okay, so let's go ahead and see which side do you guys want to find first. Say why, guys. Why? Why? Okay, so we know that they're 45, 45. So therefore, my legs are going to be congruent to each other. So therefore, if this is 3 square roots of 2 over 2, what would this length be? The same. 3 square roots of 2 over beautiful 2. Now let's go ahead and find the value of x. Which one do you guys want as your figure 1 and figure 2? This one, figure 1? This is figure 2? Okay, so figure 1 over figure 2. Okay, so let's go ahead and create our first ratio. We need to find x. So I'm going to go ahead and write x as my figure 2. Figure 1 is corresponding to, x is corresponding to square root of 2. Okay, so I got that down. Equals 3 square roots of 2 over 2 is part of figure 2. So 3 square roots of 2 over figure 2, over 2. And this one is corresponding to 1. Okay. Perfect. So let's go ahead and multiply. Cross multiply. Let's see. We have x times 1. X square root of 2 times 3 square roots of 2 over 2. So let's go ahead and do that fun part. So we have 3 square root of 2 over 2 times square root of 2. We're going to put a 1 underneath my square root of 2 and we're going to multiply across. So we're going to have 3 times, or 3 square roots of 2 times square root of 2. All right. Over beautiful, what is 2 times 1? 2. Okay, so we already did this part in the last example. What was square root of 2 times square root of 2? Equal to square root of 4. And then what is square root of 4? What is it equal to? 2. So this is going to be, let me write it up here. 3 times beautiful 2 over 2. And what is 3 times 2? 6 divided by 2. So 6 over 2, which equals 3. So therefore, x equals beautiful 3. Not too bad, huh? It's just our radicals that we need to simplify. Here. ¿Listos for the last one? Yes. ¿Qué pasó? This one? Where? Right here? It's my little arrow. They're my little arrows. No, it's because that last example we said we already know what square root of 2. Let me go ahead and let me do this one again so you guys can see it step by step. So we said we had 3 square roots of 2 times square root of 2. I'm going to go ahead and write it underneath 1. 3 square roots of 2 times square root of 2. 2 times 1 is 2, so we're going to write it underneath 2. These two items multiply. Since we have a radical, that's what I was saying. We have a radical, we can go ahead and multiply the items inside together. So we can multiply 2 times 2. So that gives me 3 square roots of 4 over 2. Now we can go ahead and simplify this part. Square root of 4 gives me 2. So that's where I get 3 times 2 over 2. Gives me 6 over 2, which is beautiful 3. So that's what I was talking about. Whenever we have radicals and we're multiplying them, whatever's inside of our square roots or radicals, we can go ahead and multiply together and simplify. All right, ready for the last one. Let's go ahead and do this one, last one. Square root of 3, 3 square roots of 2. And we have to find the other two sides, x and y. Okay, with your neighbor, go ahead and find the value of y in this case. Find the value of y with your neighbor. Who wants to help me out with the value of y? There, Miriam, what did you get? 3 square roots of 2. The reason being is because we have a beautiful isosceles triangle and we have our legs congruent to each other. Therefore, this is also 3 square roots of 2. Raise your hand if you got that. Awesome. Now, what is the basic triangle that we're going to use as our figure 1? Diego, help me out. Sombrano. 1, 1, and 2. Not 2. Square roots of, it's not the same thing. This is 2. This is square root of 2. 2 is 2, square root of 2 is something else. So 45, 45, and our beautiful 90 degree. So let's go ahead and see. This is figure 1. Figure beautiful 2. I'm going to do figure 1 over figure 2. What is the side that we need to find out here? X. So that is that going in my figure 1 or figure 2? Numerator, denominator. Denominator. So this is going here. What is the corresponding side to X on figure 1? Square root of 2. Beautiful. Perfect. Now, let's go ahead and use the given side. So the given side that we have here from figure 2 is what length? 3 square roots of? Does that go on figure 1 or figure 2? Figure 2, so 3 square roots of 2. Figure 1 is corresponding 1. So this is going to go over 1. Perfect. Now let's go ahead and cross multiply. Beautiful. So 1 times x is x. Square root of 2 times 3 square roots of 2 gives me. What did you guys get? What is 3? There you go. 3 square roots of 4. Simplify, we get 3 times 2, or yeah, 3 times 2, which is x equals beautiful 6 here in this case. Woo-hoo. Not too bad, huh? Raise your hand if you got that. Yay. Okay, you guys ready for the homework? Yay. Oh, wait, we're going to play Kahoot. Okay, so let's go ahead and play Kahoot.